Hello? Are we on? We're on at 1080p, and I have no transcoder. Feels bad, man. Well, I haven't streamed since March, and it's now August. I suppose that's fair. Right, I have a new setup, and just want to make sure everything is working. So I should be streaming, and I should be recording. People should be able to hear me. Oh, hello. 715209 and Vera Lucas, hello. So if you can hear me and you know that I'm streaming and you can see me, then I suppose it's working. So I've been playing around with a couple things. So let me just run the thing I've been playing with. So this is the traditional test triangle, right? Hey there, TS Jost. It's an early morning for you, late night for me. This is the traditional test triangle that everyone who does any kind of introduction to graphics programming will end up drawing. So this is being drawn with wgpu. And on top of that, I'm drawing an egui GUI, which isn't completely working, and I think the objective for tonight will be to get this button to work. So it should be where I hover over it, should light up. When I click it, it should increment this number, but it doesn't do that right now. So two different things. wgpu is drawing the graphics, and egui is sort of like a GUI that's on top of the graphics. And I'm kind of learning both at the same time, you know. That's never gone wrong, has it? Bitsig, hi. Pretty sure it's early morning. Okay, I'll accept that. So egui is a imperative user interface. So everything is like, do this, like put a label, put a button. If we clicked it, do this. Put another label. And this is run every time we repaint. So it's inside of a big closure that I assigned to this variable called redraw that I am using. I'm going to call that whenever we want to redraw the screen. Yes, immediate mode. It's also called immediate UI. I'm not sure, but it's been a few days since I've read it. But I think it just says it's an immediate mode GUI library for Rust. Yeah. Yeah, so I have made a redraw function, and I have made a resize function, which are pretty much the bare minimum you can get away with. And then I have an event loop that depends on what it calls depends on what my backend is. So I actually have two backends. I was playing around with full tick and then also winit. So I think winit is more popular. Its event loop kind of looks like this. You run it with the closure, you get an event and a control flow, and a third thing, I'm not sure what it is. But the event tells you if you should redraw, and window event tells you if like got resized or a close was requested, other things like clicking buttons. So one problem I have is I haven't fully connected it to egui. Like if you move the mouse or you click a button, those events don't get back to egui in any way. So I need to solve that problem. And that's probably what I'm going to work on right now. So maybe I should explain more of what I've been doing. Where should I start? Let's just start at the main. Where is main? Way down here. So a couple things. wgpu is pretty chatty in its logging, so I've like toned down the logging for two of its modules. So I figured out this is how you do it, at least with Simple Logger. I also learned that Simple Logger has an env logger emulator, which is really cool, which means I can use Simple Logger, and it also has the environment variable support if I wanted it. Is it a IMGUI rewrite? I think if you read the page there, they talk about it being like inspired by IMGUI, but yeah, it's like totally all in Rust. So this is setting up my logging, right? Default level of info, we allow environment variables to change it, and then we override two settings. That noise outside. I think my vacuum cleaner is like, my robot vacuum cleaner is running over something. Anyway, parsing argument variables. Do I actually have argument variables? Oh yeah, that's right. I'll explain that in a bit. We have one argument variable, one argument, command line argument, right? And that is this window implementation. So I'm using clap, the declarative way of in clap to describe command line arguments. And so I have two things, winit and full tick, right? So which one I pick, we're going to create the corresponding backend. So they both conform to this abstract window trait, which we're going to be modifying, right? These are the four things I needed just to get off the ground. Needed to run the event loop, which I kind of showed a glance of, right? We need to be able to create a surface, which is the thing we're going to draw to. Like it could be a buffer or a texture or a window, something like that. So in this case, it's going to be the window. And we need to get the width and the height of the window. So we'll construct either the winit or the full tick backend, which is just connecting us to the window manager and all that. And we're going to go through this subroutine I made called wgpu init, and we're going to get out a bunch of wgpu stuff. So the surface is what we're drawing on. Surface config has things like how wide and how tall the window is. Device represents the all the resources of the GPU that apply to that surface, I believe. And then the queue is how we issue graphics commands to like update buffers and draw and stuff. This is I'm probably using incorrect terms, but I'm just learning wgpu myself. I've been using OpenGL up until now, and OpenGL is kind of old. wgpu is nice in that it's a Rust implementation of I think it's web something, like a newer graphics API, and they have in wgpu they have wrappers for all the different graphics APIs: OpenGL, Vulkan, Metal, DirectX, and WebGL. So it's like write once and run everywhere. Web GUI, okay, yeah. So I'll get into that in a second, but it's basically setting up all the resources that we need. Then I kind of extracted out all the code that has to do with constructing all the geometry and stuff for the little triangle I'm drawing, and put it in this triangle model struct. And then this is how we construct the object that egui lets us use to draw a UI. It needs to have access to our graphics resources. It needs to know the format of the surface, so whether it's RGB scaled or not scaled or BGR or whatever. And I think this one here is the pixel density, which right now I've hard coded at 1, which I'm going to regret later when I run this on like a Retina display. And I forget what this one is. If I click this, maybe I can see. Okay, it's the depth buffer format. So I'm not using a depth buffer, so I don't care. WGPU is a cross-platform safe, pure Rust graphics API. Yeah, exactly. Isn't that what I just said? At least partially. Okay, so that gives us something we can draw the GUI with, right? And then I wrap into a reference counted pointer, basically. The surface, the device surface config, so that we can share it between our two major closers here, redraw and resize. They both use it. It's a single-threaded program, so I don't need to worry about sending them. So we can just use RC instead of ARC. And the surface config I put into a ref cell because we need to mutate it. And that's when we resize the window, we're going to be mutating it. Actually, right here is where we mutate it. if I didn't do that, we'd have a borrow problem between redraw and resize, and I'd have to use what is it? I have to use mutex or something like that, right? Write once, debug everywhere. No, no, no. It's Rust, so we don't debug, right? It just works. Okay, so redraws I'll get into in a bit. Resize is pretty easy. Whenever we're told the new window height and width, we grab the surface config for mutation and we mutate it, and then we reconfigure the surface with that. So pretty much all of the objects like surface, device, queue, they're immutable, and I believe the way that it works is it's really just a handle to the state, and so it synchronizes internally, so we don't have to worry about them. We don't have to get mutable access to them. They're just immutable handles. Surface config is the exception because we have direct access to the structure. I think it's this surface configuration. And we get that back out. There we go. Yeah, it's just a plain struct. So it's not, unlike the other ones, it's not just a handle to an object. It's a plain old structure. Anyway, before I get into redraw, let me show you what I did for the wgpu init, because this sort of encapsulates a lot of what I learned about how you set up wgpu. And I'll try to like compare it to OpenGL as much as I can. Hey there, Togglebit. Good morning. I've been doing good. This is a great time for you to join because I'm just going to start to talk about what I've learned so far about wgpu and how it compares to OpenGL. So, I learned a little bit of Metal and a little bit of Vulkan also, so I can kind of see that wgpu is fitting more of those modern graphics library structures and data types, but it works with OpenGL too. So, first, we are creating an instance. And I believe all that we do with the instance is we use it to get access to the adapter, which represents the graphics library underlying. So there's an adapter for Vulkan, there's an adapter for OpenGL, adapter for DirectX, etc. And instance lets us kind of get access to them. So we're saying we want potentially to look at all the backends that are available. And I have no idea why the DirectX 12 shader compiler reference is here, but it just is. So we don't care, default. Surface is independent of GUI layer, right? So we can create a surface from the instance right away. And I think, yeah, we create it because we're going to then list all the adapters and ask each one, hey, adapter, do you support this surface that we've created? And if it supports drawing to a surface, basically a window surface, because there's potentially could be adapters that draw just to textures and don't work with actual windows. So maybe some of them will say no, but probably they'll all say yes. And I am also printing a log for that because it's kind of interesting as I was learning to see what adapters I could use. So anyway, we're going to here commit to finding an adapter. So we're going to go to the instance and say, instead of listing adapters, we're going to actually ask for one. And here are basically our criteria. We don't care about power, but we could say we want high performance, high power, or low power. You know, if we wanted a power efficient program that doesn't care about high performance stuff. I think this fallback adapter is for like software versus hardware. What's the word? Like you can fall back to software, and this is basically saying the adapter has to be compatible with the surface again. So sort of like what we said here. And we need to await on that it's asynchronous. And since we're calling it from a synchronous context, a nifty way to do that is to put it inside an async block. And then I don't have any task infrastructure, so I'm just using the one that's in futures, the simple one. Like if I was using Tokyo or something else, we would use that, but this is bare bones, like just block using the thread zone executor. Okay. And it's possible we fail, so we bail if we fail. And we're going to print out what adapter we got. And then another async block is needed to ask the adapter to give us a device. And the device is sort of like the factory for all the other resources of the GPU. And yeah, again, here's our opportunity to say, here are some criteria for the device. And I think this is one I picked because this lets us pick one that's compatible to WebGL. So it's kind of like a universally capable device. And I know I'm glossing over a lot of the details, mostly because I don't understand very much of it myself. I followed a tutorial to get this far, and I only sort of at a very high level, vague understanding of what I'm doing. But anyway, now that we have a device in a queue, we're going to, what are we doing next? We're setting up a surface configuration because we're going to configure our surface at the end with our device and then other things that we select for that surface. So first, we're going to get the adapter's capabilities. So we're going to, and here I did a debug log to see, well, what kind of formats, surface formats the adapter supports, presentation modes, alpha modes, all that stuff. And we end up saying, we're going to use this surface to render to. I believe that's what that says. The format is basically find something that's sRGB. And I'm going to end up changing this later because I found an egui gives me a warning about it. It says that, hey, you're using an sRGB format, but we prefer a non-sRGB format. So I'll probably have to change this. Anyway, we're going to tell it that the surface should be as wide as our window is and as high as our window is. And I'm not sure what this means, but I think it has to do with the order of presentation commands, but I could be wrong. And I don't remember exactly what alpha mode means, but from what I'm seeing here, I think it has to do with actually, I'm not even going to say because I don't remember what it is at all. You know that feeling, toggle bit? So if and when I need to come back here, I'll just look this stuff up to figure out what it is. I just like having an initial working platform on which to experiment with. And even though I don't completely understand all these little bits, it all works, so I'm happy. So we have the surface, which is our representing our connection from the graphics library to the window, and then device is our factory for getting all sorts of other things that we need from the GPU, and Q is we'll be using a bit. It's how we actually do drawing commands. So that was the wgpu init. So we have all those resources, we set up these closures, and we go into the event loop. So the event loop for winit basically waits until the window system or window manager gives us events, and one of the most popular events we'll get is, hey, please draw something. And then another popular one is, hey, your window got resized, right? And then a somewhat less popular, very useful one will be, hey, the user wants to close you. So those are some of the more important ones, right? The most important one being the redraw. So what happens in redraw? We already talked about resize and exit. It's pretty self-explanatory. Get into that. There, Pollux. It was not you. Various reasons why I haven't streamed in a while. But we're doing it tonight or this morning, however you'd like to see that. I know. I'm sorry. But I'm back. Hopefully I'll stay back this time. A lot of it was that this setup is pretty new. My computer's new. I have a new cat. There's a lot of work being done in the house that was very disruptive. It was also summertime, so a lot of things added up to where I wasn't streaming. There's also work keeps me pretty busy. Yeah, I have a new cat. Maybe we will see the cat on stream tonight or some other night. Right now the cat's locked out of the office, so we're probably not gonna see the cat this time, but I could put a picture up on the Discord maybe later. Well, thank you, Pollux. I hope you're doing well too. All right, so let's get in. Let me explain what redraw does. And again, a lot of this is based off the tutorial I went through, which if you would like to see the tutorial, I believe all that I did was I went into a browser and typed in like wgpu tutorial, and I just hit one of these things. Maybe I could find it right off the bat. It might have been this one. It might have been this one. Yeah, it was this one. So yeah, I went through this tutorial, learn wgpu. So I recommend that you do the same. You want to get to where I am, which is not very far, but it's a launching point because I have a working app. So we're going to end up cloning those reference counted pointers, because if you don't, we're going to get Rust borrow checker complaining that can't remember exactly what it is, but that it's the borrow something about with the borrow checker. In fact, let's just comment that out and see what Rust complains about, because I don't remember. Yeah, use of moved value. It was moved into the closure. Right, so the pointer was moved into the closure for redraw, but then resize also has a move. So I clone it in order for redraw to get, right, because the move happens here, right? So we want to get our own local copy of each pointer, and the local copies of the pointers move into this closure so that the original ones remain available for the other closure. That's why I'm cloning. See, I have to remind myself why I have these clones. Here is where the mutable state for our UI is currently living, which is a horrible place, which I'm going to move soon. When in doubt, clone everything, 715209. And then, when you learn better, go back and refactor. So anyway, we're going to move into the closure a bunch of stuff, and I think I am doing that just so that it can own its own copies of these things. Actually, I wonder if I still need to have this. I might not need that at all, now that I think about it. Should I experiment by commenting this out and seeing if it still works? That might be superfluous now. No, it's still needed because found unit, expected a closure. That seems like I'm imbalanced on the braces or something. Oh, right. We need a closure because we're boxing a closure, because my event loop expects a boxed closure. So that is why I have a closure. We must have a closure. This stuff is so that we can get local copies of our pointers. Okay, so that's why we have closure. Right. Now the actual GPU stuff. We call get current texture on the surface to get, I believe this is a surface texture. And we then take the surface texture and we create a view into it. And my understanding of that is we do this in order to get access to that surface texture. It sets up the context so we can draw onto the surface. Recently spotted an albino Dalmatian. It was the least you could do for him. Spotted. That's funny. Thank you. And hi, Mr. Balrock. How are you doing? Another tip nowadays is ask ChatGPT to help with the borrow checker errors. Not a bad idea, actually. I haven't been able to play with that yet, but I'm looking forward to that when I can. anyway, we have our view into the surface that we're going to draw. Now we're going to create a command encoder, and it's an encoder of commands to draw stuff, is my understanding. So with that encoder, later we're going to be asking it to do things like start rendering. And it kind of ushers all of our drawing commands into the GPU. We don't do much other than give it the framework for, hey, begin rendering, do this stuff, but we'll get to that in a second. Then here's all the egui stuff, and I'm going to collapse that for now. Just from a very high level view, we need to tell egui what the inputs are. So do we just hit any keys? Are we moving the mouse? Did we click a button? And then we tell the egui, generate stuff to draw based on that input and the current context. So the context can change. It remembers. It's somewhat stateful, right? We're doing this every time we redraw. That it's an immediate mode GUI, so it doesn't retain much. It retains some, but it's mostly immediate mode. So it ends up laying out and redrawing every single frame, basically. We get this output. It's a combination of certain things. So one of the outputs is the shapes to draw. Another output are the changes to make to the GPU textures. So like what the actual text is will be in the textures, and the shapes of where the text goes will be in the shapes, right? So we're going to use this helper from egui to tessellate, basically turn the shapes into triangles. And so egui primitives ends up being a vector of clipped primitives, or basically a vector of triangles, right? Then we're going to get access to our surface config, because we need to take the current width and height of our surface and give that, put that into a screen descriptor, which I believe we're going to use right down here when we tell egui to update all of the vertex index uniform buffers that need to be given to the GPU to draw all that stuff, right? So width and height, here again is the pixels per point. That's like the screen density. And again, I'm hard coding it to 1. I need to fix that. It won't work on a Retina display very well, but it works for me so far. From the textures, we tell egui, go ahead and use this device and queue and all that stuff to queue up basically the wgpu or the GPU commands that are needed to update the text that we're drawing, right, or the colors of things. So everything that goes into the texture buffers in the GPU get updated there. So it's generating drawing commands and putting them into the queue internally to this update texture. And then update buffers, again, like I said, it's updating vertex index buffer, so all the shape information. That's why it gets the primitives, the triangles, along with the device, the queue, the encoder, and how big the screen is and all that. Then the render pass is outside of egui. This is where I'm going to draw the background and then the triangle. And I think, yeah, the way I ordered it is we begin the render pass by going to the encoder and say, hey, we're about to render. And this is where in OpenGL you'd traditionally do things like GL clear color. So we say, this is what we're going to clear the screen with this color. So it's dark green, right? And there are other things in here that don't really matter right now, but there are things like how you initialize the surface when you're about to draw to it. And we have no depth or stencil attachments. We just have a render attachment, right? Just the pixels. And then I'm going to draw my triangle, which I'll get to the triangle in a bit. And then after we draw the triangle, then we tell egui to go and do its rendering. So it takes those the triangles that we generated from output, that screen descriptor, the render pass we just made, and then it queues up all the actual draw commands. So before, all we really did was update textures and buffers. We didn't draw anything. We still needed to talk to the GPU to do that, so that's why we had to give it the device and the queue, right? Here, though, we're telling it actually do the draw commands. And then dropping the render pass tells it basically we're done. Encoder finish closes that up. There was one point here that was important. I believe it's shown here that render pass has a limited lifetime. It is actually borrowing from the encoder. So you get back, the render pass is borrowing some stuff from the encoder. That's why you have to actually drop that render pass before you call finish, because otherwise you'd have a borrow problem. In fact, I could probably see that if I comment that out. Yeah, here we go. It says, cannot move out of encoder because it's borrowed. Borrow occurs at 356, which is where we made the render pass. And now we're going to move, right, finish actually moves out because it takes self. It doesn't take a borrow, it actually consumes self, right? So it's basically destroying the encoder. We can't destroy the encoder while the render pass is still borrowing from it. So we have to drop the render pass, which is basically a signal saying we're done issuing rendering commands. You can now finish encoding and button up a big job to queue to the GPU. And then I believe output present, right, takes what all the things that we drew to the surface and presented on the screen. And then as a follow-up to egui, like part of its output are the textures that we can free that it doesn't need anymore, and we go ahead and free them there after we're done drawing. Hey there, Endorn, good morning. I can't respond for the next 30 minutes, that's fine, you're driving. Drive safe, my friend. And 715209, the goal today is for me to exercise my atrophied streaming muscles and describe what I've been doing off screen in this particular hobby project, where I'm learning wgpu and egui and eventually rapier, which is a physics engine for Rust. So you can kind of see where this is going. I have a new graphics library I'm learning, a new GUI library I'm learning, and a physics engine. We're going to be playing with simulations that use both physics and 3D graphics. So that's the longer goal in general for playing around with these new libraries, is to play around with simulations. But yeah, the short term, just learning wgpu and egui. I'm just beginning, and I did some stuff off stream the last few weeks that I wanted to cover here and just practice streaming again, because I haven't streamed since March. So I hope if you were following along, you kind of get the gist of the redraw. Really quick again, we are getting a view into the surface that we're drawing. We're setting up an encoder for drawing commands to post to the GPU to do stuff. We run the one render cycle basically of egui saying, here's some inputs, which right now are empty. Give me the output that corresponds to that input, and then pick apart the triangles and the textures. Describing the current surface, we tell it update the textures so that the colors and the actual characters to draw on the screen for the text are in those textures. And then here are the buffers are the geometry information, like where to draw shapes and fonts on the screen or on the surface, and how big to draw them. And then we're beginning the render cycle, which is basically clearing the screen with the color and saying other initialization steps, which are mostly empty right now. We're drawing a triangle. We're telling egui to do its drawing, and then we're taking that sequence of drawing commands that run through the encoder and saying, okay, encoder, finish that up. It gives us one job that we submit to the queue, and that's where it actually gets sent to the GPU, and it's done over there. And it's all synchronous, because by the time that returns, we're ready to tell the output. The output was the surface texture, right? We tell it to go ahead and present that to the screen. So if you can think of it as double buffered, we're drawing to the off-screen one while the on-screen one still shows something, and then present kind of exchanges those two, flips them. And then we free any graphics textures that egui doesn't need anymore. So that happens once per frame. So you imagine that this has to go at 60 frames per second. We have a budget of 1/60 seconds to do all of that. Let me show you the triangle model I made. I haven't run this in a while, so if you just joined recently, here's what all that looks like. So this is the egui part. The button doesn't work yet, but when we get that to work, whenever I click that, it should increment this number. And the background and the triangle are just straight wgpu calls, and it's the kind of the hello world of graphics programming. Your first objective, once you get a window to pop open and draw a background, is to usually just draw one triangle and do something fun with the colors in it. So that's what we did, and that triangle I'm going to go into now. So I can't click on that. Oh, holding down the wrong key. So triangle model, I have it in a struct. This is kind of what it looks like. So we need to have a shader, and we need to have a layout for the render pipeline, a vertex buffer, an index buffer, the actual render pipeline, which ties all that stuff together. So like, here's our how we use the vertex shader. Here's how we use the fragment shader. This is the kinds of things we're drawing. And that's all the state information we're going to need every frame, right? So kind of like the objects that we only need to set up once at the very beginning. So in more detail, device, like I said before, it's like sort of the factory for a lot of different GPU objects in wgpu. So we use device to create shaders. We use it to create pipeline layouts. We use it to create buffers. We use it to create actual pipelines and other things. So creating a shader is kind of fun. You give it a label. I'm not sure what the label is used for yet. And other than that, you basically say, here's my source code. And by the way, it's in WGSL syntax. And I believe that's because there are several alternatives. We could write our shader in GLSL if we wanted, or SpearV, which is, I think, popular with Vulkan. And there's one I've never heard about called Naga. Don't know what that is, but yeah, anyway, I wrote out mine in WGSL. And here I'll show you what a WGSL shader looks like. So if you've seen shaders before, it's sort of self-explanatory. The syntax is different. We annotate on every attribute its location using @location, parentheses, the location number. So these kind of tie attributes of our input to slots on the shader. So you can think of like the shader having an array of input slots. And so each time the shader runs, it gets the slot filled with one of the positions and one of the colors of the input, right? And the output also has slots. So there's a one that's built in called position, which feeds directly from the vertex shader to the fragment shader, right? It's like the fragment shader is going to get the rasterization of all of the clip positions we output. And then the other slot is the color that corresponds to that particular position. And then when it rasterizes it and does a bunch of interpolation to feed the fragment shader a color for that pixel, right? And then we annotate with @vertex where our vertex shader is. I think this VS main has to correspond to what we say over here somewhere. I don't remember exactly where. Oh yeah, right here, entry point. Whatever we say as entry point here has to be the same as what we named the vertex shader. It gets a single input, which is that struct, which sort of incorporates like what are all the input slots that go into that shader, the vertex shader. And same thing with the fragment shader. It also gets an input. I don't know why I put that on one line by itself, and this one I put on the same line. I don't remember. Probably not important. But yeah, the shader itself is pretty simple. We compute the clip position from the input model position and then just turn it from 2D to 3D. What is it when we have a fourth coordinate? Homogeneous 3D coordinates, right? So the z coordinate or z coordinate is always 0, and I think the w, which is only really used when we're doing perspective or other kinds of projections. We just make it 1, so it's basically what's the term? Like it has no impact. So when you convert it back down to screen coordinates, the x and y stay the same. Z just needs to be between 0 and 1, otherwise it's not shown. These two really only come to play when we actually draw 3D stuff with different projections. So you can see like we're just passing the position as is, adding the other coordinates that we don't really need, but we'll use later when we do 3D stuff. Same thing with the color. I'm just taking the color and setting the alpha channel to 1. And then the fragment shader, it doesn't do anything at all. It just says, hey, I'm just going to use the color that the vertex shader came up with that was then passed through the rasterizer that did all the interpolation between vertex points, right? So pretty simple. Anyway, that's how we describe what we're doing to draw the triangle. And it's not much, but we still have to say, well, we do have a vertex shader. It's in this module, which we compiled up here. I think this is where we do the shader compilation, I think. Or maybe this is where we tell the compiler where to get it from. Anyway, either way, the module has both the vertex and the fragment shaders. We tell them both of them to go to the same module, just with different entry points. And buffers here is how we describe on the CPU side the same thing that we told the GPU over here, these slots. So if we go to this description here, we're saying, hey, the position is in this structure wherever position is offset within that structure. So it's going to be 0, and color, the offset of color within vertex. So that we need those offsets down here when we're constructing the equivalent to what the shader says here is what we're saying here, that the slots are position and color. And they're in these two locations at these two offsets on the CPU side, and these are the data types. So float 32 by 2, so it's a vector of 2 elements of floats, each one 32 bits, and then color is a 3D. Or yeah, RG and B, right? So 3D vector for color, 2D vector for position. And we also have to say overall, like to get from one element to the other, that's called the stride. It's going to be the size of that vertex, and wgpu wants it as a buffer address, not an integer. Anyway, I'm over describing the description. But yeah, all of that is setting up in the render pipeline, hey, when you go and construct the vertex shader, here's how you connect the vertex buffer on the CPU side with the shader side, the attribute, those slots that go into that shader program. That's how it gets connected. For the fragment shader, the inputs come from the previous stage, so we don't actually have inputs or buffers, but instead we tell it where. I think what they use the word target because they're saying, well, what are we going to do with the output of the fragment shader? What's its target? And I think this is saying we're just going to replace whatever pixels were in the surface before. You could also just blend with, like if you have multiple passes, you might have one pass draw something in the back and then the next pass blend something on top of that. So we would use a different blend state for that. And there's other things like what the format of the surface is. Is it RGB or BGR or scaled RGB? That kind of thing. Right. there's a little bit of subtlety here because there's a render pipeline and then there's a render pipeline layout. And right now, there's not much to my render pipeline layout. There's just a bunch of empty vectors. But I believe the layout for the render pipeline describes things like the uniforms. I think that's what the constant ranges are, but I might be wrong about that. We don't have any of those yet, so it's empty. But if we add them, I think we would add them here. And when we create the pipeline, we reference back to that layout to tell it about those higher level constructs that might be common between different pipelines that have the same layout, if that makes sense. Hey there, Lobsang 2. How's my keyboard? Doing pretty good. Here it is. Still using it. So, yeah. Primitive. Where basically this is a very overly worded way of telling the graphics library, we are going to draw triangles. They are going to be counterclockwise order of vertices. We do not want to draw back-facing triangles, so cull them for optimization, right? Other options would be cull the front-facing ones or don't cull any of them. Cull basically means to strip out of the list of actual things to draw to save time. We're going to fill those triangles. I think this has to do with, it's the depth buffer and how we're going to apply clipping to it. That's not set up right. And then I don't know what conservative rasterization is. These kinds of things I'm not so familiar with yet because they're more advanced or they're different enough from OpenGL that I don't recognize them. But I think I just copied them from the tutorial. We have no depth or stencil. If we did, we would have to specify it here. And multi-sample has to do, I think, with how I think it has to do with the fragment shader and how many passes of the fragment shader are run, which are then averaged together to do anti-aliasing. Hey there, Utsby. It's funny how the starting point for low-level graphics coding has stayed this arduous slog through dense config for decades. Yes, but there are reasons for that, right? So if you remember OpenGL 1, a lot of this was hidden away for you behind a layer in the library that kind of just did it for you. But then that was pretty limiting if you wanted to do more advanced things, which game designers wanted to do, right? So they're like, we need direct access to the different drawing stages within the GPU, like the vertex and the fragment stages. And that turned into, okay, so we need to allow you not only to have access to the vertices and the fragments or the pixels, but we need to make them programmable. So thus we had to have these shaders and shader programs. And yeah, a lot of it used to be simpler because the details were buttoned up and hidden away. But once you open that Pandora's box of providing a more low-level access to it, well, even now when you want to do something simple, kind of forced to set up this boilerplate. I did try to hide it away, though, inside of the constructor for this type. So all I need to do is click that, and I can completely forget that I needed to send up a render pipeline layout and all that junk. Useful to go through it, though. And we only need to do this once at setup time. That's the other reason why a lot of it up front is complex. When we actually do the drawing, it's a lot simpler. We're basically saying, here's a buffer of geometry. Here are some constants, and we call them uniforms, right? Take that buffer of geometry and just feed it to this program one at a time and make it draw triangles. Go, right? All the detail to turn that into what exactly it should do is kind of described up front in these pipeline description structures, right? So we do all the complex stuff at an initialization time so that when we're actually drawing, the overhead is minimal. Everything is kind of streamlined at that point. So that's my take on why it's an arduous slog. It's an arduous slog because we are arranging a lot of things in advance so that when we're actually drawing, it's streamlined. And it's very customizable. It's streamlined, but still allows you very deep control and customization. And I'm scrolling around for no reason. Yeah, that was triangle model new, right? Go back to where I called that. That was a while ago, so I'll have to go back a few times. Excuse me while I jump around. Okay, yeah, that was, I clicked there to show triangle new, right? At some point I attached the geometry for that. Did I skip over that by accident? Was it in new the whole time? Oh yeah, I did. It was when, yeah, because I jumped from render pipeline layout to render pipeline. I skipped right over my buffers. So we have two buffers. We only really need one buffer, which is all of our inputs. Here is what to make the triangle look like. And it's very simple, right? It's these coordinates on the screen. That one's the top of the triangle. This one's the lower left, and this one's the lower right, I believe. So make the top red, make the lower left green, and the lower right blue. Or maybe it's blue and then green. Anyway, we split into two buffers because I anticipate later a more complex model will have a lot of the vertices shared between triangles. And the nice way to lower the memory usage for that is to reuse vertices for different triangles by having a second buffer called an index buffer. So you can think of it as one extra level of indirection. When we draw, the first level is going to be draw these indices. And those indices map back into the vertices list. So 0 says, okay, pick that vertex, and then 1, pick that vertex, and 2 would be pick that vertex. So if we wanted to draw a square instead of a triangle, we would have 4 points, not 3, right? But we still have to describe it in triangles. So one way is to break the square up into 2 triangles, and those 2 triangles both share 2 of the vertices. So you'd have 6 vertices. You could list all 6 out here, but a cooler way would be to only have 4 of them listed, and in the indices you'd say 0, 1, 2, 2, 1, 3. You know why the config is there? It's just amusing to show a beginner write these 300 lines of code. Well, that's why I'm spending so much time kind of going over it. But I don't expect anyone who doesn't already know a little bit about graphics programming is going to understand it all. I guess I'm assuming that maybe a lot of you are maybe familiar with something else like OpenGL or DirectX, and because I'm kind of describing it the way I'm learning it now, where I know a bit about OpenGL and some DirectX, but I don't know nothing about wgpu until I followed this tutorial. And that I followed it and typed out this code, I'm going over like, what did I just learn? I just learned that there are these structures we set up that are roughly corresponding to this and this in OpenGL, and it kind of helps me remember and make sense of it. Yeah, I know you're not criticizing me. I am just giving some more background to it. Anyway, I just think some of this stuff is fun to play with, and it's intimidating until it becomes less intimidating when you have someone else kind of walk through some of it, and maybe it makes a little bit more sense or is a little bit less intimidating afterwards, right? So, okay, to sum up, the vertices describes the points in space we want to draw. Indices allows us to reuse those points using less memory if we want to. We want to take those vertices and those indices and put them in GPU memory, right? So first step is to describe them, which we did here. That's in the CPU. How do we get from the CPU to the GPU? We tell the device, we want to create a buffer in the GPU. Its contents will be this junk in the CPU's memory space. We're going to use it in the GPU for vertices. And then when we do the same API to create the index buffer, this time we give it the different pointer and we say this usage is different. It's going to be an index buffer, not a vertex buffer. And that lets the underlying GPU library kind of optimize. It might handle the memory for the vertices different from the way it handles the indices. When you think about it, indices are always going to be used linearly from beginning to end, but vertices are going to be randomly accessing it potentially, right? So you might have different cache behaviors based off of whether we're going to use the buffer for vertices or indices. Yeah, I think that's interesting. That's my guess why we give this usage hint. But anyway, it just from the top level view, what it's doing is saying to the GPU, I want to move this stuff from the CPU to the GPU memory and represent it with as a buffer with this handle that we're going to use later. We end up using that down when we're drawing. When we draw the triangle, we say, hey, render pass, that we set up before. Use the pipeline that we described. Basically, the pipeline, again, is all that junk that we set up saying, use these shaders, here's the structure of our input, all that good stuff, right? It's all now very quick and easy to say, like, remember all that junk we set up at init time? Hey, just use it. Just use that, and by the way, here is the index buffer we want you to use, and here's the vertex buffer, and here's the index buffer that we want to use. Okay, ready? Draw it. So this is the what do you call it? The code that's going to be executed many times, like 60 times per second, right? If not more, if we have more render passes. So we want this to be very short and sweet, saying use this pipeline, use these buffers, go and draw it. And we don't really give it very much information because a lot of it's already kind of internally initialized in that pipeline, and all the memory is already in the GPU. We're just saying use this slice of what you already have, which basically is all of it. We use slices here because it gives us the flexibility of saying, like, we might have the geometry of several different objects all packed into one buffer, and for this particular triangle, maybe use a certain subsection of the buffer for that triangle, and for something else, use a different subsection. So it's kind of an optimization there. Put everything in one buffer and then pick out slices of it for different objects. And then, because it doesn't actually know, actually, you would think that when you set the index buffer and you tell it how much of the index buffer to use, it would know how many things it's going to draw. But for some reason, we have to tell it again. It's kind of clumsy here in Rust because I haven't cleaned this up, and the types are different. Draw indexed wants a range of U32s, right? But length always gives us a U size, so we have to go from U size to U32. So I used a as. Maybe there's a better way to do this. And then it wanted it as the indexes described as a range. So I had to do, say, okay, 0 to that number. So however many indices we're going from 0 up to, but not including that number. So my indices, I think there are 3 of them. So this all boils down to 0.3. Basically saying, use the first 3 indices. And the other 2 arguments is a base vertex and a number of instances. Oh, that's because we might want to draw 100 different triangles that all look the same but are in different positions on the screen. And if we were doing that, we would have a range of more than one thing here. And base says where to start in the index buffer. So to start at the beginning, draw one triangle. That triangle has 3 indices. Let's set up some shaders and pointers. Let's invent the universe. Exactly at TS Jost. So all of that to draw a triangle. So the good thing that I've learned is that things are really complicated when you set things up. And it's kind of demotivating at first because you do all that setup just to draw something simple. But then you realize, hey, there's not much now to go from this simple thing to something really complex. The only difference is in how many points of geometry, and it just goes back to the model that we made of this triangle right here. The only thing that really grows and gets more complex are these. And typically, you wouldn't even put this in their source code. You would put this in a 3D model file and use a loader library to just load it in. And to make the model, you would use something like Blender or something else to. So it's completely removed from the code. The rest of the code basically it's the same, no matter if I'm drawing one triangle or drawing several million triangles, right? It does. Things do get more complicated if you want your model to look any different from a rainbow object, of course, right? To draw something other than this cool rainbow, couple things, right? You had to have a more complex shader program that actually does some work to figure out the colors to draw based off of, I don't know, lighting or reflectivity of the surface or things that are around you, right? And you might have more inputs to your vertex shader. So you might want to have normal vectors in there or something else. And uniforms to describe where the lights are in space. So things do get a little bit more complicated, but not a whole lot more, I think. I think you kind of go through learning all of the setup for this crap. There's a lot of it at first, but then you're really not adding too much more to it once you've set up the initial stuff, which is what I've heard is the same experience people have learning Vulkan. Really arduous, and there's a lot of stuff to learn at first, but then once you learn a little bit, you get a lot more done without needing to learn a whole lot more. So it's just, I think there's just a steeper learning curve for Vulkan, but it's going to be the same experience, right? You just are setting up a bunch of intricate little pieces, but once they're set up, then you've built the machine, and maybe you add a few more things to the machine to make it a little bit complicated, a little bit more complicated. But other than that, it's most of it's in the setup, right? Tried using Vulkan and it crashed your GPU. Sorry. Okay, I think I've completely explained my program to death, and it's time to actually do some work. Listen, if anyone else has any other questions. So again, my work right now tonight, after explaining stuff, is I would like this button to work, which means I need to give the event feedback from winit needs to actually go back into egui so that it knows I'm moving the mouse and clicking here. Right now it doesn't know that, so number one, it doesn't even know that I'm clicking. Number two, even if it did know I was clicking, we're not telling it, there's no trigger to cause it to redraw in the first place. So those two things, passing the input to egui, and also we need to redraw when egui says that we need to redraw. So as we move the mouse over here, once it gets inside of this button, egui is going to say, hey, we need to redraw because we need to highlight that button now. And when I click it, it's going to say, hey, we need to redraw again because you clicked something, which will maybe change the way the button looks and also change this text, right? So again, we need to get the input into egui, and then we also need to listen to egui when it says to redraw. We actually need to trigger the redraw. So let me do the event stuff first. So the event stuff, that is right here. Right now, the event stuff is empty. I need to get events from winit back into egui. I was looking into this library called egui winit, which has something to do that. I think it was called state egui input. Right, and okay, and then so if we use one of these things, these state structures from this egui winit, they call it an integration, right? It's this library that's used to integrate egui with winit. then if we give it the if we call it on whenever we get an event, we call on event, and then later we call egui input, it'll give us the raw input rather than me just creating one by default. So I guess what that means is at this point where we need the input, we're going to call this egui input from some state structure. So let's assume that, okay, we're going to need to get that raw input, but let's assume that we have some state, like, what do I want to call it? State. Window state for now. And then we're just going to assume that that's something that we can call this, something we can call without any arguments, and it'll just give us the raw input. egui input, I guess. We'll call it that. All right, so right away, Russ is going to say, I don't know what the heck you're talking about with window state, so that needs to be declared somewhere. I'm going to want to declare that, I guess, up here somewhere, right? It doesn't really matter where. Let's do it here. Let the window state equal, what's it going to be? It comes from window. So I think I need to add something to my app. Maybe it just is window. So like, instead of window state, I can just say window directly. So window will provide egui input. And that abstract window is just my abstraction so that I can like have an alternative to w init. I could have full tick or something else. So we'll just add it to the abstraction. It wasn't Windows state. What was it? What did I just call it? egui input. Right. egui input. Borrow self, and it needs to give me back an egui raw input. Right? Okay. So we're going to run into two problems right away, and that is that that has no implementation in either of my concrete classes. So let's add them. I'll add the full tick one right away because that's going to be, I'm not going to worry about that tonight. I'm just going to have it return egui raw in, if I could type, input default. Right? That's just, in fact, we're going to do that on the winit host as well, just to make sure that we can still compile. So this should be the equivalent of what I had before, only it comes from the abstraction directly instead of, it comes from the abstraction rather than creating the default directly here, right? So we shouldn't need that anymore. So the input's going to come from our window abstraction. I just need to solve this problem, whatever it is. Use of moved value window. Okay. It's because it got moved into the closure because we used it inside of there, right? So I'm going to do the same trick because window is a handle. I should be able to say window equals window clone. Actually, it's not a handle, is it? I think I will RC wrap it first to make it into a handle. RC new window. So then I can clone the RC. Cannot move. Oh, because I need to do the same trick around resize. I basically need to clone it twice because outside my closure I needed a third time. So what was the trick I used? Did I move right inside the box new? I did it, right? Right, I did that. And then I did a... Did I have two moves? No, I didn't have two moves. The move here goes to there. I just had an extra brace. Let the formatter sort it out. Unused? Oh, is this not the right closure? Did I screw this up? Okay. That should have given me a clone. Why does it think that it's been moved? Cannot move out of RC. Move occurs because the value has the type boxed. Doesn't implement copy. Wait, where did it get moved? Cannot move out of an RC. Is that because of the signature of event loop? Oh, because self is box self. Move out of an RC. Shoot. That means I need to do like a borrow here, right? Or is it like reference it and then that? Yeah, I can't. My rust is rusty. So yeah, okay, it wasn't. Yeah, I didn't need it here, so I can undo that. The restarts didn't actually need to use window. The problem is that I'm putting in. I'm window is a boxed dyn abstract window, right? A boxed trait object. And I'm trying to stuff it inside an RC, and it didn't like. It's okay when I used it inside this closure to call egui input, because that borrows from the trait object. That was fine. What it doesn't like is when I try to pull it out to use it with event loop, because event loop uses a boxed. Oh, right. It's consuming self. It's not taking a reference. Okay, that's the problem. This is going to steal it out of the window, but we can't do that if we're borrowing it in redraw. So I need to take the part, yeah. I need to take the part of self we actually use in event loop and separate it out from this egui part. So why don't I just split this into two things? What if I have two trait objects? Because we'll have the abstract window, and then we'll have like the egui integration. And then because it already has egui in the name, let's just get rid of the input part. And I guess I can have one return the other. Why not? Function get egui integration. You guys tell me if I'm doing this wrong. I think this will work, right? Dyn, or is it impl egui integration? Not impl. Only allowed in function on a trait method return. So do I need to do a dyn and maybe box it? I guess we'll box it on the way out, right? There's an error associated with headline, probably because it's not implemented, right? So hold on. So then full tick needs to have one. Yeah, okay. Inside there. And then we'll have another struct right now. Egui. Can't use the same name, right? What if I call it the full tick egui integration? And then impl that for think I got this backwards. Yeah, I had it backwards. Implement the trait for the concrete type. And then that has just a default input. So this can just return egui, full ticking egui integration, right? That, right? Doesn't like that, why? Return type cannot have an unboxed trait object. It doesn't have a size. Oh, so I need to box it? Because it doesn't, because the caller won't know how big it is. So then we do box new. Now it's unsized, right? And to make it consistent, it needs to be declared that way in the abstraction. All right. And full tick is okay. It's winit that doesn't, it's not complete yet, so let's just replace that. And we'll just say that this is the winit egui integration. What's it not like about that? Cannot find it in scope. Oh, gotta use it. Why didn't I have to do that for full tick? Did I do that and it just wasn't watching? I just wasn't watching. Look, it did that. It did the import and I didn't even notice. Okay, back to here. So where's the error? It's probably inside here somewhere. Yep. Yeah, it's that there is no method there. Right, before we move or borrow out of window, so it could be anywhere, we need to get the integration out of it. Was I going to do it right there? I think I was. I'm going to do it right here, right? So let the egui integration. The window dot get egui integration. Now we have that integration. We can use it down here. Egui integration input. All right. So I didn't need to clone the window at all. I can remove that. Okay, and then what's the event loop has a problem? Cannot move. Well, why is it still complaining about that? Does it think that I'm borrowing it somehow still? I didn't have this problem before. What's the problem? Why? I didn't change that line, did I? Okay, I did something. What if I don't do that? Grab this line again. I just grab that line again. I wish I could copy paste from here. It won't let me though. I want to stage. I wish there was a button here where I could say, I just want to put the old line next to the new line. I'll just type it again. Egui raw input default. Okay, and then don't do that line. It's still complaining. I must have screwed something else unrelated up. Let me find what it is. Oh, it's because I put it into an RC. So get rid of that line, problem goes away, so then I can get the integration out and use it down here. Okay, so it just can't go into an RC because of the fact that we're consuming self, not an RC self here. Actually, maybe I didn't need to separate it, right? No, I still do need to separate it because redraw ends up getting a piece, getting that integration piece out of the window. So we need to get it out before beforehand so that when we move the window in, we've already gotten the integration out of it so that we can independently use it inside of redraw, even though window is consumed. Cool. So this should have a net effect of nothing, but it should still run and not break anything else, right? So verify this works, and then I can actually put in the real integration of getting the input. So we did nothing, but we've opened the path up to now where I can actually fill this in. So I need to see how was that done. There was some kind of state it needed to have, right? First, I need to make sure that we're using it. We're not. So it's egui w init. egui w init 0 dot same version as the others. I think it's like co-developed with egui and the egui wgpu. So now that we have it imported in our project, we can use it, right? How do I use it again? I get a state structure. How do I make a state structure? It's called new. Oh, it needs the raw display handle. Okay, we'll give it that. So it's egui wnet state. Oh, I know why it's not auto-completing, because the name goes first in Rust. State is go away. Go away. It is a state. Okay, so we do have errors. That's weird that it took so long to right. It goes the comma there, right? Right, now I need to fill in a state here. Egui init state new, and it needs the display handle. I think I could just give it self.window. Not self.window. That window is a winit window, platform window. I thought that implemented the display handle. See what the error is. Oh, just needs to borrow it. Sure, you can borrow it. Cool. So now we have a state for the integration. I should be able to use that state the way it was intended, right? Just call egui input on it. So we would say self.state.egui input. Is that not right? Oh, that gives us a borrow. There's a take one version. Prepare for a new frame by extracting the accumulated input, as well as setting the time and screen rectangle. Okay, so we actually want the take one, right? We need access to the window, though. Okay, that's no problem. Well, I think we could just clone the window. Actually, this is a different window type, isn't it? No, it's a WNet window. It's the same window, and it only needs a immutable borrow. So take. So this needs a window too. Just window. Yeah. So it just needs window. Self.window. Clone it. Is it not clonable? Is it copyable? Can I just copy it like that? Yes? Okay, so then this takes a window borrowed. Oh, is it not copy? Doesn't implement the copy trait. Okay, so we have to share it between the two wrappers, right? Well, that sucks. I just RC it? Where's the other one? Here it is. So then, borrow. Wait, hold on. Why did it not handle one of these? Handle these, right. This needs to be put in RC new. I close this because it's making it hard to see everything. And what is this error here? What's the recommendation? Is it that we need to actually reach inside of that? So what's dereference and then dereference? Yeah, there's that little trick, right? So the dereference for RC gives us the actual window, and then we're just borrowing that window. You would think that that wouldn't be necessary, but Rust can't make the leap from going from an RC'd window to a borrowed window. We have to first dereference the RC to get the window and then say, okay, now borrow that. Probably have the same thing down here, right? Dereference the window. And then here I actually need to clone it. And then same thing down here, right? And then this needed another argument. Cell, oh, it needs to mutate. So it needs to be mutable. Which means that the it has to be declared as mutable in the trait itself up here. And down in the full tick one, which is empty, you have to make that consistent. Okay. And which means that this needs to be declared as mutable. The egui integration has to be mutable itself, right? Okay. And that goes away. Okay, we're good. Make sure that this still runs. So now it's pulling in our integration, and it will get all the input that we've collected. Problem is we actually haven't given the state the collected events. That's the last part of this. Oh, which means that the window has to retain a reference to the integration. So I gotta have it get it. Okay, it's gonna be interesting. Yeah, so this still won't work because although going back to here, although we're taking the input that's collected in the state, we never gave the state the inputs in the first place. Was this saying I don't need to do this now? Oh, that just works now. Why is it that I had to do it here, but I don't have to do it here? Huh. What's different with new? Oh, because it's not that it wants a reference to the window. It wants a reference to some trait object which implements a type. That's why we needed that here. We don't need it here because it knows the type. It knows it's a w-init window. And this already is a w-init window. So it can make that leap from RC to borrowed window directly. It's this it can't because it's this this is a concrete, but the new wants abstraction. Got it. Okay, so right, we need to get the state, the events. So the events happen up here, right? So I think in addition to doing what we're doing here, we give that state the event. So it would be like self dot egui integration. And I need to see what is the function to give it an event. It'll be here somewhere, right? On event. call this when there's a new event. So what do we do with the event response though? Consumed repaint. If true, it consumed the event. Okay, so only pass on events to the rest of my program if consumed is false. Repaint, do we need egui to refresh because of this event? So we need to feed that back as well. Okay. How do I go back from this? That okay. So we're going to call on event. We're going to get it back in event response, which will do something within a bit. We need to have the egui context, and we need to have the event. I don't know if I have the context here. Oh, we don't have the context. Shoot. The context is in main back out here, right? We need to somehow, okay, so maybe instead of making the context here, we'll get it from the integration. Okay, so let's do that then. This abstract window needs to be able to get the context as well. Box, dine. Actually, no. We can. It doesn't need to be abstract. We can just return an egui context, right? It's just context, I think it is. So then this should be more specific. Okay, so same thing I was trying to do with the integration is just by default until we have something, we'll just return what we constructed in main down here, which is egui context default. We'll just return that when asked. Or we can just put it in here. Egui context. Yeah, so here, let egui context equal that. And where did I move that? I didn't move it. I didn't even type it yet. I have it here. I need to paste, copy, and paste it. Oh, I put it. Where did I put it? I put it here, but I wasn't working on that yet, right? I was working on this one up here. Yeah. So goes right here. So we don't want to actually pull it out. We want to borrow it, right? I'm not completely sure about that, but we'll go with that for now. So that's just borrowing self.egui context. I'm pretty sure I'm going to change that later. I just want to get this to compile again. So I'll just copy from full tick, which is to declare it in the state of the window wrapper. There. And construct it along with the window here. Down here. And wrap it. Okay, so yeah, I have to actually put that in the state as well. I will just do that right now. So its integration will be a reference, shared reference to this guy. Okay, then so this getting it back out then will be a reference to the box, right? Let me think about this. Does it need to be RC is sized? RC is not sized, so I don't actually need a box there at all. I can create this out here when I create the thing in the first place. Hey there, striped monkey. I am doing great. Although chat has been very quiet. Everyone's been like laser focused at me, or I've completely bored everyone to tears, which is fine if you're trying to fall asleep and you come to this channel and you're bored to and fall asleep. Hey, I've helped you sleep, right? That's fine. But yeah, for whatever reason, it's been pretty quiet. Let egui integration equals some default integration. Okay, so we don't use self here, we just use window, and here as well. And then we include the integration along with the context there. Should satisfy that. Is it in the wrong order? Mismatch types. Okay, so it needs to be put into an RC. RC knew that. Hey there, Bog Devil 13. How are you doing? Please feel free to ask me stuff. Otherwise, I'm just going to assume you guys know Rust and you know what I'm doing, and I'm just going to go full speed ahead. So we're not returning a box anymore. We're just going to return a copy of our reference. So it would be self.egui integration.clone. Is that because I didn't update? Yeah, I didn't update the main trait. That still says box. Fixed. Okay, that's happy. Okay? This, I want to fix one error at a time. I need to go back to full tick and fix that one. That needs to be an RC. So we need to do the same kind of junk here. Self, whoops. Just a bit early for you. It's 3 a.m. It's hard for me to have a friendly time for everyone, Stripe Monkey. What I did is I waited until the sun rose in Europe, and then I figured all my European friends, they should be up by now. It's Monday morning for them, so. But unfortunately, that means it's going to be late night for everyone in East Coast US. It's hard. It's really hard to satisfy both East Coast US, Europe, actually all three. West, East Coast US, and Europe is really hard to satisfy everybody. Integration alone. I make a lot of typing mistakes still to this day on my keyboard. I think it's because I'm fighting against decades of using QWERTY keyboard. Because I'm not using a QWERTY keyboard, I'm using the Rusty keyboard, which is Colmac mod DH layout. I'm still fighting it to this day, but I like the challenge, so I will continue with that. It's Monday morning for you, yes, TS Just. Oh wait, not Monday morning, Tuesday morning. I get confused because for me it's Monday, for you it's Tuesday. It's not Monday morning for anyone anymore, right? And everyone's either on Tuesday or it's Monday night, I guess, right? Does RC need to be imported? It does. This needs to be full tick. Okay. And then I need to make one. So same thing I did for WInit. I need to make it. This is a lot of boilerplate. I know. But it has to be because the integration is going to be different. It's going to be a completely different type. Do we really need that? No. We actually can leave it empty, right? Yeah, that can be completely empty. Okay, so back in the main, what's the problem here? Cannot borrow data in RC is mutable. Oh, did I say input was mutable? I did. I need to make that immutable. I need to put this in a ref cell, I guess. Yeah, okay, so we'll make it immutable. And we'll just encapsulate what we need inside a ref cell. So we can do this. We're advanced Rust developers, right? We know what to do. So when we know that state is immutable, we can fix that by putting this inside a ref cell. And then we would do borrow mute. As long as it's imported, this works, right? Then when we package it, we do ref cell new. Yay, we have defeated the borrow checker by hiding our mutable state inside a ref cell. The stream 24 hours, easy peasy. Wish I could, but there's these things called sleep and work that need to be dealt with. Okay, so I have the integration available. It doesn't need to be mutable anymore because we're using interior mutability, which is nice. It should be getting the input, right? As long as we have filled the input in here, which is what I was going to do here, right? Self.egui integration. Which is our seed. So I just need to have another method of that feeds it an event. So let's just declare that first and then we'll use it. So there'll be like do you guys like to have the trait implementations first and then the custom implementations second? Or do you guys prefer to have the custom implementation first and the trait implementation second? These are these like burning questions that I can never get a satisfactory answer to on my own. Seems to me like this should go first, and then we list all of our trait implementations because we might add more and more later. They're kind of add-ons, right? At the core, it's just a structure, so it has some methods that are implemented for it, and the trait implementations are add-on, right? They make it more useful. That's how I'm justifying this order. So I think that's good for me. So function, what are we going to call this? Feed input event, or yeah, just call feed input event. So it's going to take an immutable self. It's going to take whatever the type is of an event, which I don't know. What's it called? Just called event. Ooh, got a nasty type to it. Ew, that. It's borrowing some lifetime and it using a T type. What's T? Whatever the event loop is generic over. Okay, we'll figure this out. What is the event loop generic over? Over unit. I have no idea what that type is. The return value of something, I guess. Okay, so event is this, and we already know the T is unit. I don't know what that lifetime is though. Will it just take a fill in the blank lifetime? Let's see. Then we'll just try to call it up here. Self.egui integration dot feed event, right? Wait, why is it not liking it? Feed input event. Why can I not call that? I think the cat might be yelling at me. feed? Feed. Okay, what does it not like about this? Syntax error. Okay, where's my syntax error? Is it on self? Something completely wrong with that line. What is it? I think self is not in the event loop, right? This consumes self, so maybe what I should be doing here is pulling up the integration before we go into this loop. Let integration. I think that's what I'm supposed to do, and then not use self here. It just gets pulled out of self, and we use it inside the event loop. But no, there's something here. Syntax error. Oh, is it because it's inside of a match event? Okay, that's what it is. It's because there's actually a match event here. It's before the match event we need to do that. There we go. It takes an argument. It takes the event as an argument. Problem is that we can't let it consume the event. We need to just borrow that event. So I think we can just let it borrow the event. Yeah, I was in the match arms. Thank you, PhD Horrible. I figured it out before I saw your chat. But I should have looked at the chat, and you would have helped me find it much faster. It's a multiple impl T blocks with group functionality. Your private interface and different impl from public. Sure, some people might call it blasphemy. Oh, multiple blocks? I don't find that blasphemous. So you would have multiples of this, maybe even in different files, right? Where you might have some other function, right? I think that's fine. You might even put these in different files. I guess if, in this simple case where I have just two bins, the, I guess, module private function and then the trait implementation, like, I'm kind of curious, do people put the private internal functions first and then the trait implementations if they were to put them together, or would they put them the other way? If they put them in different files, it's a moot point, right? Stripe Monkey, you like to put the traits after, but you also like splitting it without a trait. Splitting impulse. Well, in my case, I have to implement a trait because it all feeds back into main, which doesn't know at compile time which one I'm going to pick, right? We're going to pick one of the others based off of a command line argument. We don't know the type. So we do need an unsized trait object of indirection. Fundamentally, it has to be a trait object the way I've designed this. I don't know any other way to do it because we don't know until runtime which type it's going to be. There's probably a way to do it without trait objects that involves like turning it on its head, which would be a fun thing to go through, but let's make that a separate endeavor. So feed the event. That was going to be self.state. On event, right? Okay, it's inside a ref cell, so we got to borrow it. On event takes a mutable self, which means we're going to need to borrow mutably. On event takes the context, which we don't have. Do we have that? We don't have it yet. So okay, so the integration also needs access to the context. Let's just say we're going to have it. So borrow from self.context. And then egui context. I think I named it. The event is a borrowed event, which we already have. It's called event. Okay, so we need the egui context to be shared between the window and the integration. Not a problem. I think I already have it rseed. Oh no, I don't. Okay, so it also will be rseed. I wonder why the context is needed for. Oh, because that's the state storage for the thing, right? Okay, so that needs to be also shared between these two parts. What's wrong here? Arguments to this method are incorrect. Oh, it's just the return type. We're gonna discard the result at first. Actually, I don't need to do that. I can just put a semicolon at the end. Why is it not like the event? A window event is not an event. Oh, that's right. There were two levels of event in this thing, right? So I need to move this down to here. Oh, no. No. It's the other way around. It doesn't take a window event. It takes an... It doesn't take an event. It takes a window event. Okay, so that means that I did have it. I did need to move it there, and I also need to change the type to window event. And that needs to be imported. Why does it not let me import it? Oh, window event just has the lifetime as, okay, fine. There, I did it. Okay, so this needs to share the context. So, egui context. Oh, the kitty wants in. I need to go get the kitty. This problem. Oh, I need to RCify it. Okay, just a second. The kitty demands entry into my domain, or her domain, in which she deigns to allow me to share. All right. Oh, now you want attention? What if I'm streaming? Okay. Okay. Good. We're all good, right? Why do we have a warning here? Oh, no. How about you go here? Everyone can see you. Can we see your head, please? That is the princess. Oh, she's walking off screen already. She's shy. She's going to attempt to sabotage the screen by shutting down the computer or something. Or maybe like sit on the cables behind the monitor. Anyway, it's just complaining that I didn't use the event. Right, so I had a feeling that I'd have to do that to quiet it down. Okay, so it's going to borrow the state, to pass it the event. It also shares the same GUI context. I have a feeling that this is redundant. I can just call this context. Okay, now if I did this right, we should get the context update. So let's, you know what we should do? We should info this. Let event response, I think it is. Yeah, let's info that so we can see it. Just to make sure it's working. So event response probably does not implement display, but you know, who knows, maybe it does. Does not implement display, so we'll see if it implements debug. It does not. Well, that sucks. How are we going to print it out if it doesn't implement debug or display? I guess what we'll do is we'll look at its fields. Consumed and repaint, right? I don't care about consumed. Actually, maybe I do. I can combine these. And delete that text. There we go. All right, let's run it. What time is it? It's 12:30, and this is going longer than I thought it would. Isn't that usually the case the first stream after like a long time? Okay, there we go. So cool. I think it's working because see how I'm dragging the mouse around and it says repaint false all the time? If I hover right over the button. Oh, actually no, it's going between true and false. It wants me to repaint sometimes, but not other times. I think I want to see what event it is then. So I had that in there, but I commented it out, I thought. Oh no, I had it as a debug. Let's make it an info. I want to see what that event is that makes it want to repaint. It shouldn't need to repaint on every mouse move. Maybe mouse move does need it to repaint. Let's see what. So it's a cursor move to cause the repaint. Okay. I don't know why, but it wants me to repaint every time we move the cursor. These other ones it could care less about. Cursor left, close, that makes sense. Axis motion it doesn't care about. Cursor move it cares about. All right, so I guess for us to see the results, we need to actually cause a repaint. So let's make that just a return value. Bool. What is the Boolean type in Rust again? Oh, no, that is the correct type. It just needs me to return it. Event response repaint. Okay, and then we're going to use it up here. We'd put this back to debug. Or I forget. Okay, then I probably don't need this to be an info anymore, like that a debug. And we just need to use that now. So let repaint equals that. So if repaint, how do we, oh, here it is, window.request redraw. That's how we do it with winit. So hopefully now, when it asks us to repaint, we forward that request on to winit, then we should be redrawing. So let's try it out. All right, here's our window. Oh, look. When I mouse over the button, it actually paints that I'm in the button. Oh, the click handler works. Yes, it worked. Hey, that was our objective for the night. I like it. Okay, so we have a full loop now. So input to output. I hope you're just as excited as I am that I got it to work. I should clean it up before I call it a night, though, right? I don't really need this debug anymore, right? Do we want the consumed? We probably do want the consumed, right? So let's just give it. Why don't we just give it the whole event response? What's the type on that? It's on the state, which is, oh, it's from this other library. Can I just import that? And we'll just return the whole thing. And go up here, and so this is event response. The other one was consumed, right? So the idea is that if consumed is true, we don't need to do this match event. So I would say if not event.consumed response, then we can match event. Can I put that on the same line? I don't think. If always needs braces, right? I just don't like the idea of that extra indent. Ooh, fancy. I know, Sir Flabbergast. Isn't it fancy? I just need to actually do stuff for real with the GUI stuff. Now that I have a full loop working, I can add all sorts of fancy gadgets. You guys seen the gadgets that you can have? egui. You just go to egui.rs. Look at all these cool gadgets. I was looking at this the other day. My favorite one is probably plot. Look at that. You can like mouse over individual points. Isn't that cool? All this cool stuff. What's really cool is that this is sort of highlighting how the GUI library works in a browser because they implement a integration for WebGL. That's probably my favorite. The other one that I thought was cool was Bezier curve. I like Bezier curves. I like the concept. Look at that. Look at that nice Bezier curve. But yeah, spinners, custom widgets, we got sliders, different kinds. We have tool tips. It's awesome. I like it. Anyway. You suddenly need that. I know you need it. You need it now. Let me make sure I didn't break this. Kitty's meowing at me. I have not yet had my foot attacked tonight, but I know. I'm glad to be back, Sir Flabbergast. Multiple different circumstances caused me not to stream for the last 5 months, which I regret, but, you know, some things you can't control in life, right? Yeah, I didn't break anything. I need to add something cool to this. Can I just add a spinner? See how easy it is to add a spinner. I want to have some fun, so find where I'm actually drawing my GUI. Actually, one thing I could do tonight is extract this out to a function so it's not so indented. Let's put another label and say, look at this cool spinner. And then we'll just add a spinner. That's all we need to do. Look at that. Compile, link. Ooh, look at this cool spinner. Now I just need to put it on the same line. Oh, you see the bug? It only works while I move the mouse around. Okay, so I'm missing something. I think I know what it is. I remember reading that there's like another place where egui can say you need to redraw soon, or you need to redraw immediately, and I'm ignoring that information right now. Yeah. I think I'll leave it for the next stream though. Button works. The spinner works as long as I actually am feeding it inputs to cause it to repaint. I'll fix this next stream. These basically state-driven refreshes that had nothing to do with input. Did you pick egui over say IamGUI for a particular reason? 2 reasons why I picked egui. One was that I saw Musen using it, and second is that it's all pure Rust. So completely arbitrary reasons to pick it, but ever since you guys convinced me to look into Rust, I've been super, super excited about it, and any chance I get in my spare time, I am very biased, I am preferring pure Rust stuff over other things. So those are the only reasons. Pretty much arbitrary. Don't need this format here. The other reason I pick it, and actually another reason in general that my stream these days is so Rust focused, is it keeps me away from other subjects which would be difficult for me to justify streaming. You know, I need to keep my stream separate from other things like work, right? And so work, we definitely don't do anything in Rust at work. So Rust is like, as long as I'm doing like educational stuff and hobby stuff and not doing things that are work related, then we're in safe territory. If I start to get too close to what I do for work, then we got issues. So that's maybe another reason I'm picking egui, is that it's safely within the solidly the Rust area that allows me to stream it. Okay. What was I doing besides? Okay, yeah. I was gonna say we're gonna fix this in the next stream. I don't need to leave myself a note. That should be. Oh, I wanted to refactor this out to a function so it's not so indented, right? That shouldn't be too hard, because all this needs is actually it doesn't need anything. It just needs my state, which is the count variable, right? So what if I just made, instead of this count variable, what if I made the state a separate thing? And what if, let's go ahead and do the right thing here and call something like the overlay. Or is overlay too generic? Like, I want to make a structure which represents the state of the UI on top of my graphics. How do you call it GUI? How about just GUI.rs? The graphical user interface. Because everything else I'm going to draw is not going to be part of the, well, is output part of the interface? I guess it is. Maybe GUI isn't the right name. It's the interactive part of the user interface, or I guess it's the informational overlay. I kind of want to call it overlay. That's maybe not the right name. Overlay or info overlay. That's a terrible name. I don't know what to call this. I'm gonna call it a terrible name. That will inspire me to try to find a better name. How about that? So let's call it a struct. I could spell info overlay. Terrible name. And here we're gonna put our count in there. So count, which is uint, I guess. Okay, and then impl. So overlay. Let's impl default for overlay. And all right, it's not going to give me good. I'm hearing that noise. What are you doing, cat? Huh, I don't know. Hopefully the cat is not destroying something behind the corner there. Yeah, it doesn't know about, it won't give me a compiler help until I declare it as a module here. So let's do that. Info overlay. That's just telling me the same thing. So now it is going to give me help. What's the Rust equivalent of that? Is it use size? I'm getting my languages screwed up. uint is from what? Can't remember what language uint was for. I guess several languages have uint. Okay, so the default count, I guess we want to be explicit here, it's 0. And then might as well make that public. It can be derived. Well, sure, it can be derived, but I'm going to add new stuff here later. Okay, it's easy enough to auto-generate that code. So for now, we'll derive How is this index here? Not pound. It's having a moment. Having a moment. It is pound. How come it didn't like me typing that? I guess it needs to be complete before that works. Wait, what? Oh, because I have this impl. There we go. All right. Let me just impl something different. How about we impl custom, and then I wanted to call this like draw or something, right? Draw. What is it called in egui? That's a good question. Somebody moving this. It's called run. It's called run. Run. That's a terrible name. Why do they call it run? Shouldn't it just be called like? Let's call it like what I think it should be called. There's either draw or render or loop. How about loop? Loop, the reserved word. Maybe that's why they called it run, because there really isn't a better name. Run will mutably borrow self, and it doesn't need to return anything. It's going to also borrow egui context. We don't need to say egui, do we? It's just text. And then what's the other thing it needed? It needs the raw input. Raw input. We can actually import that, right? So as long as we import the correct one. It actually is going to return a bunch of stuff, isn't it? It returns the full output. So that is of type full output. The borrow needs to be go with the type, not the name. You know what trips me up is that it goes with the type here, but for self it doesn't. It goes in like I always think that this should be self mute self, which I guess is another way you can write it like that, right? But they prefer that form instead. It trips me up though because the borrow is on the left of the entire thing, and the name is to the right of it, but all the other ones the name is to the left, and there's a colon, and I get all tripped up. You int, I int, we all int for hey there. Hey now. Okay, this goes away. And the whole point of this was I wanted to pull out this entire stuff, all of this out. All of that out and plop it into here. And this is just what's it? Replay select all matches. Shift Super L. There we go. Raw input. Oh, this doesn't borrow it, it consumes it. My bad. Okay, we're going to need to import all of the things from egui that I'm actually using here. Okay, so here's where we mutate self. Why the double indentation here? I keep forgetting to close this tab. I'm sorry about that. So what should we do about that comment from Slick Liability? I think I should press this button over here. There, I pressed it. Thou hast been booped. Okay. So self.count goes there. Oh, that's right. We can't do that. I have to put it over here. Whoops. There we go. There's probably a way to put this inside of here, but I haven't learned that yet. What will the tooltip tell me? Consider using positional instead. I think it should be able to parse that, but who am I to judge, right? Okay, so run, not used. Make it public so that it will, because we're going to use it. It's not used, but we're about to use it right here. So instead of a count here, I want what did I call it? I call it info overlay. Info default. Okay, and then so this is info overlay dot run egui ctx and raw input. Borrow the context. Done. Whoa. Are you guys seeing that? What's going on with my graphics? That's weird. Something with a virtual machine is on the fritz. I'm just gonna pretend it's not there. Maybe it'll just go away. Cool, we're back to 0 warnings. Let's run that. Yeah, I'm running a virtual machine. Run this Ubuntu. I think that's why the compiling is slightly slower there. Okay, didn't break anything. Still haven't fixed the spinner thing, but we're gonna do that next stream. But I did do one thing which I wanted to do, which was flatten out that info overlay and put it in its own module. I guess I should refactor this a little bit more because I still don't like that indentation. How would I refactor this? Maybe this context run goes outside. Then I don't need to pass these in. I really just need to pass it this closure should just be what the run is. So then it would take a context. That's a borrowed context anyway. Yeah, so then I wouldn't take the raw input. This line would go back into main. We'll keep it, we'll call it run for now, but how would this go? It would be like this, and then this would be this part goes outside. There. Right, and then we replace the closure with just info overlay.run, right? Or do I still need the closure? I think I still need the closure, right? But oh wait, no, there's a it needs the self though, right? So I need to have the self there and then put context here. This is egui ctx. Egui raw input. Oh, right. It doesn't need the full. Wait, what? Right, that run doesn't deal with the full output anymore. It's just the interior. This. So this is removed. So we got one level indentation out of that, at the cost of of this being slightly more. But now we've also removed the input completely out of it, and as well as the output. So now this is just concerned with what to draw. I still don't like the indentation level. You know what I kind of feel like doing is making this another function, a function of self and the UI. Can I do that? Yeah, this can pass on the mutable reference, right? So I could extract that. I could take this out completely and make another function. I'm gonna call it foo because my brain is melting and I can't think of a better name, but I'll think of a better name in a second. This was UI, right? UI. Or in which I'll paste all that stuff. Import it. Is it mutable UI? Yes, it is. Then this is just foo. Self foo UI. There we go. So now the run just describes the frame in which we're going to draw with the margin and then show. Okay, so really what foo is, it's drawing the inside of my frame. So let's call this a main frame. Okay, so we make a central panel defaults. In that, we make a frame with a margin of 10 pixels, and then inside the frame, we show the main frame. So really, it's main frame content, or central frame contents or something. Main frame content. Okay, I like this because the indentation is not too bad. I've separated the see now the cat's pulling on cables behind my computer. Not allowed to do that. Hold on a second. Hold on, I need to turn off the camera for a second. She's being a naughty kitty. I'm gonna be naughty. The cat's trying to get my attention to play with her or something. So I have banished the cat from the room temporarily. Yeah, I can't show the cat actually because I realized the cat's collar has my phone number on it. So if I were to show the cat on stream, I'd have to take off her collar first. I didn't realize that until a little bit ago. Okay. Yeah, so I like this separation. So the overall UI now shows the dimensions in the frame and the margin, but then the content is separated from that, and there's not so much indentation. And I could probably start to structure my UI like this, right? So it's basically functional. Whenever I want to describe the content of some pane, I make a function, and the function just takes the UI and just like populates it. The cat was proprietary to your employer? No, it's always the other way around. We are the property of the cats, right? That's the way you got to think about it. So if anything, my cat owns the company I work for. And so, yeah, I don't know how to explain how I was legally able to evict the cat from the room using that logic, but I'll think of something. Maybe I'm being I'm committing foul acts of treachery that I will soon regret, as my face will be ripped off in the middle of the night. Who knows? Corporate takeover. I like to think the cat's the cat is the owner. We are the cat's humans. All right. Anyway, I wanted to refactor that. I got it refactored. If anything, I need to refactor all the junk out of here. because I need to separate things like the render pass is one thing, right? And then submitting the work for the GPU and presenting as something else. And then around that we have some suffix work for egui, and then we have the prefix work, and then we have the drawing work here. So like there are really three phases here. There's like prefix or setup work, and then that goes down to actually there's four parts. So there's the egui like rendering or running, the egui running part, and then that actually goes here, right? Yes. So because the primitives are used here. So like here's the egui running part. Get input, produce output, right? Then we have the prefix to the drawing, which is like tessellate the geometry, update the textures, upload the buffers into the GPU, right? Then we actually have the drawing phase where we start the render pass, we draw stuff, and the render pass, right? And then we have the actual finish up and submit the whole job to the GPU. Bang, it's all done on the GPU. And all the drawing. Actually, I guess that this goes with the drawing, right? Where do we get the encoder? No, the encoder is used in this first stage. So this really should go in a separate stage, right? Finish the encoder and submit the work, present it, and then... So where I've put these blank lines, I feel these are like boundaries between functions that I need to refactor out, right? This is one function, this is another one, this is yet another one. This is one, which I'd probably call draw, and this is presenting, and this is egui follow-up, right? I want to go to bed, so I'm not going to do it now, but maybe next stream, where I've broken these up between blank lines is where I will refactor them into other functions. Right now, all of this is being described in a closure that we put in a box. I don't know if I want to keep it that way or if I want to pull all this out into somewhere more formally declared, like an actual function on a implementation of a struct. Or I don't know, maybe it stays as a closure that's boxed up. I don't know. Maybe it doesn't need to be any more complicated than that. Or maybe it doesn't need to be any more formal than that. This other stuff needs to be put into a function. That's log setup. That's pick our backend. This is standalone. This is make our model. This is setup egui. And actually, this context goes with this, right? Oh, do I even need that anymore? Didn't I put that in... do we reference this still? I do. Oh, that's the wrong... You know what? That's wrong. How is this working? Because, doesn't this integration input have its own context? Inside of here? This has its own context. Somehow I have two contexts. Okay, that's wrong. Let me fix that. I don't even know how that's working then. This context we shouldn't be here. Or if it's here, then we need to, it needs to be like passed into the integration. Really need to get it back out, if anything. How is it used? Over here to get the output. Oh. Well then, if why am I even like getting the raw out? What, shouldn't I just be telling the integration, hey, go deal with the input and give me the output? This should really be like that, if anything, right? without the raw input. And it should give me out the full. Well, is the context only used for tessellate? Maybe it gives me the output and the primitives then. Because tessellate doesn't borrow, it generates. Oh, it does consume the shapes. Okay. Well, shoot. It's consuming part of the full output. Maybe what I get back out is primitives and the textures delta. Okay. Yeah, it's bad that I had two contexts like that. I don't even know how that worked. So we had two separate like state information for egui, and somehow it still worked. Probably would have broken horribly later, and I would have not figured it out for a while. But yeah, we can't have a second context here. The quick solution now before I refactor, just to like borrow it out, because this just borrows self, right? Don't know because I deleted it. Put it back for a second. Does it borrow? Yes, it borrows self, and the other one also borrows self. Yes. Yes, they both borrow self, so we can just have like, this is what I'll do as a band-aid until I fix this later, is there is no context, right? So we complain. So what we do is we get a context that we borrow out of the egui integration get context. And we have to add that to our abstraction. I misspelled that. I need to fix that. No one told me I misspelled that. Seems like she will revenge. She'll get her. She'll definitely get her revenge. It'll be when I least expect it. Where's my? Here it is. Okay, so function get context self returns reference fill in the blank of actually might have to make this generic, right? Gonna return a egui context. Nope, that's okay. I just need to fill that in for yeah, actually it was there right there. So it's I guess I have to make one. Makes sense, I guess. Happen to have one there, but I just wasn't sharing it. Share it here. And share it. Just like we're doing with WNIT. Self egui context. Feel that that's redundant. Just make it context. No comma. Spell it correctly. Okay. Then I need to initialize things here, right? So this is RC new. This gets a copy of that. Reference, and then that should satisfy everyone, right? No? It's just called context. Okay. And then this one, how come it's not complaining? Aren't I missing something? Oh, I'm in the wrong file. Here. Yeah, okay, so copy what I did down here for starters. Actually, that's all I needed to do. Just let me borrow the context. And then we're using that context. We're using this is a borrowed context. We're using it to run egui, and we pass it back in. So I'll need to clean this up because really, we don't really need the raw input to be out here in main, right? Because we're borrowing out of the integration, we're borrowing out the context and just using them together, right? We might as well have the integration run egui context, get the raw input internally, so we never see it here in main, and I guess we'll pass in the info overlay to the to whatever we call this function, the run function of the integration. Yeah, so I'll clean this up later. Actually, I'm not remember to do that, so let me make a to-do note here. Clean this up so that we don't see the raw input here at all. The integration runs egui for us. We let the integration borrow our info overlay to draw it. Yeah. Hey there, NPV0, what up? You are reaching the tail end of my stream because it's 1 in the morning for me and I need to go to sleep so I can work tomorrow. I'm wrapping things up, but yeah, it's been a while. It's been like 5 months since I streamed last. I'm flexing those atrophied streaming muscles, so to speak, and trying not to incur the wrath of my new cat too much, because otherwise I will have my face clawed off in the middle of the night. But yeah, how are you doing? Hope everything is well with you. I am playing around with 2 different libraries tonight. egui, which you see all over the place in my code, and wgpu. Integrating those 2. Let me show you the example I've been working on. Yeah, I have a new kitty. I have a calico cat, 7 months old. So yeah, I'm playing around with 2 libraries. One is drawing these user interface elements, like you can have a button, you can click it, there's a cool spinner there. And then the underlying graphics library, which I'm using to draw the triangle, and the integration between the 2 allows me to draw the GUI using that same graphics library. So all of this to be using libraries that are all in Rust and have basically built-in support for all the different libraries for GPUs like DirectX, OpenGL, Vulkan, WebGL, right? My code all in Rust, pure Rust, I should be able to run this on all of those platforms. So that always is cool from, in my opinion, and that's why I've been working on tonight, learning those libraries and getting them integrated. And then there's a third library I want to add in the future stream called Rapier, which is a physics engine. So ultimately, what I want to be building is simulations, all in Rust, that use physics and 3D graphics with nice GUI overlays for control and display of stuff. So that's what I've chosen to work on these days for my spare time. Oh, I need to fix that problem too. So egui complains that we're using an sRGBA surface instead of a non-scaled. So I need to fix that in a clean way. So I got that. Need to clean this up. I need to refactor this overall main function, and also need to do the full kit stuff. Or maybe I just drop that and remove the abstraction. I have this abstraction in here just in case, because I hadn't yet decided which windowing library I liked. I like full-tick because you can incorporate low-level graphics with sort of like traditional GUI elements like buttons and labels and tabs and stuff. But on the flip side, eGUI can implement that stuff too, just in an immediate mode GUI. So we don't need full tick anymore. I could do the entire UI in egui if I wanted, right? So maybe I don't need it anymore, but that's the one I've been used to using. W-init is more of a plain thing. It doesn't give us any GUI elements at all. It just gives us a window, and it gives us window events, and that's it. So this would be a much cleaner implementation if I don't need any of the higher level stuff like full tick gives me. But I haven't yet made that decision. Lentil Stew Dragon, good morning. Long time no see. Yes, I just explained. I hope that you are here for that explanation. If not, rewind the stream like 5 minutes and you'll hear me give it again. Not to repeat it again, but yeah, it's been a while. I hope to be streaming soon. I don't want to do what I did in March where I streamed 2 days and then went off the grid again for 5 months. Let me fix this before I forget. I just misspelled this, and that's easy to fix, right? Little F2, and we just say integration fixed. You'll rewind? Yeah, what did I maybe should... One thing I should add to the explanation 5 minutes ago, something I said like a few hours ago, which is that just haven't streamed in a while because of a lot of different things. Like this, I have a new computer, my setup is relatively new, I have a new cat, and during summer it was a lot of chaos in the house. So I hope now all that is behind me and I can get settled in and do more of this stuff. I have a lot more fun doing this while streaming than I do alone. And you guys give me lots of good feedback and ask me interesting questions. And I love explaining this stuff. Hopefully you guys are okay with me explaining this stuff too. But yeah, wgpu, egui, and rapier, where I'm going to be focusing on for a while. Anything else I can do before I wrap things up? I wanted to rename this run thing, right? It really shouldn't be called run anymore because we're not running. What we're doing is we're taking an egui context and what are we doing with it? Show does return a response. We're not okay, there's two things. We're ignoring the response, which is probably, this is where why the spinner doesn't continue to update on its own. We're ignoring the response from the show. Is show the top level? Hold on. How are we using this again? Back. Final references here. Okay. Right. We're saying egui contest run. With this input, call my closure with the context. And in that context, we are producing, or we're just using the context. And the context allows us to draw. Okay, so really it should just be draw, not run. I think that's what I originally called it. I think draw is more appropriate. So drawing our info overlay means to declare a central panel, tell it we want a frame inside of it with a 10 pixel margin, and then show with what does show exactly? Shows the panel at the top level. And then they give us a closure to add the contents, which, okay, so the name is correct. If anything, this should be called add content. Yeah, that's even more correct, right? Add content. Add mainframe content. Let's just call it add content for now. Because when I add more stuff to this, when I get more specific with what I'm drawing, then I'll rename it again. Maybe this should be called show then. No, show is different from draw, right? Draw is take a context. show is taking a UI, which is a different type. A UI is what? What you use to place widgets versus a context. Which is your handle to egui. Okay, so those two things are different. Draw might not be the best name. What I'm going to go with for now. So it's just draw. But does this read okay? Get the input, get the context, take the context and run with the input, passing a closure which takes the context and draws into it. I think that works. Explaining is the best part. You like learning? I like learning too. I like to share the learning. Okay, that's good then. So yeah, where I'm gonna leave this to come back next time would be refactor on blank lines. Clean this up. What else? Oh, I should probably move the triangle model out. Refactor that. I can do that later too. Then I gotta decide what I'm gonna do next. I think what I do next is after I fix the slider, I had to fix the slider. The spinner, not the slider. The spinner needs to be fixed. Right now, if I don't move the mouse, it freezes. But if I start to move the mouse around, it updates. That's because we're redrawing on when we're told to from window events, but we're not redrawing when we're told to by the draw results. So we're just ignoring the draw results right now. And the draw results are going to say, hey, you are including a spinner in the drawing. That spinner needs to be updated in 10 milliseconds. And so please redraw in 10 milliseconds. And we're ignoring that. But after I finish that, then I can basically draw whatever UI I want. So I either can spend time learning the different things to draw in the UI, or I can go back to what the UI overlay is on top of and improve upon my triangle. I'm thinking the next step, the next natural step past a 2D triangle would be a 3D cube, right? And then like maybe click and drag to change the camera orientation. And then maybe start playing with textures on that cube. And then after that, I think the next natural step would be to add the physics engine so that the cube can move around. And then we can start shooting cubes at walls of cubes. The other typical stuff you do when you play with physics engines, right? Yeah, I think that's going to be the natural progression. So let me just make a git commit here. First stream. So I'm not actually going to push this anywhere. I'm just making commits so that in the streams repo, I can see what each stream, actually, let's just say, I'm going to say stream 1. Say stream 1, that implies I'll remember which stream number we're on. I'm not going to remember that, am I? So how am I going to organize my commits? I might have commits midstream, so then I should just do it how I normally do things. I should describe what I did. So what did I do? So I refactored out the overlay. Oh, I added the egui integration. That's the main thing. So let's make the subject about the main thing. Integrate, add egui w init integration. So do we really need to add details to this? I think it's self-explanatory. How about you say also? I can put that in the subject line. Add egui winit integration. No, let's just keep it short and sweet. So that should add the commit. Close this window. I think it's going to be it for tonight. I got to go get some sleep, but I'll either be back I hope to be back later this week, not tomorrow. See how it goes. I hope you guys enjoyed the stream. I doubt that anyone I know is still streaming this late. Oh, Togglebit's going. Great. Perfect. So we're going to raid Togglebit because he's always doing something in Rust, just like me. So I hope you guys enjoy Togglebit's stream. I'm going to go get some sleep. See you guys later. Bye-bye now.